Hi, and a warm welcome from Southampton. I'd like to talk to you about the opportunities to study geology in one of Europe's leading geoscience centres. My name is Rex Taylor, and I'm an Associate Professor in the School of Ocean Earth Science in Southampton. I contribute to around 6 modules in the Geology and Environmental Geoscience degree programme and lead field courses with our students to Tenerife and Cyprus. My research is focused on the chemical evolution of volcanoes and the causes of catastrophic explosive eruptions. I'm also the admissions tutor for geology. Last year I was lucky enough to be a scientist on a Japan-UK expedition to examine the origins of the Pacific Ring of Fire volcanoes. This involved descending to nearly 6,000 metres in a submersible to the deepest parts of the Philippine Sea. Exposed on the seabed there are lavas erupted from a volcano around 50 million years ago. We collected samples of this material using robotic arms at the front of the submersible. Our students in Southampton are now examining the lavas recovered from this mission as part of their research projects, and the results are out next year, so watch this space. We're based at the Waterfront campus, which is a community of 100 scientists and around 900 students in world-class teaching and research facilities. We're ranked number 2 in the UK for our research. So what does a geologist do? They want to understand the physical, chemical and biological processes operating on and within the Earth over the last 4.5 billion years. So it's actually a pretty big subject. It includes investigating the interaction between Earth materials and the environment, for example in hydrogeology and pollution. Most items we touch stem from natural resources sourced by geologists. Aggregates, copper, gold, lithium, plastic, diamonds, ceramics, rare earth elements, to name but a few. But a key objective is helping to develop a digital, low-carbon future. Geologists also monitor geological and environmental hazards and advise on the environmental impact and the engineering aspects of geology, including carbon capture and wind farms. They also want to understand climate change through studying the geological record. Our environmental geoscience degrees focus on the interaction between the Earth and human activity. The aim is to equip our graduates with practical and field skills needed by employers in the expanding environmental consultancy and engineering geoscience sectors. In our opinion, flexibility is key. If you're inspired by new subjects or are aiming for a particular career, you can change your degree pathway. You can switch between geology, environmental geoscience, and geology with physical geography during your degree. Also, you can move between the 3 and the 4-year bachelor's and master's programs. Entry to Southampton requires more than 120 of its points and at least 1 science A-level. After entry, you can apply to spend 1 semester of your 3rd year studying in one of our partner universities around the world, like Penn State in the United States or ETH in Zurich. In Southampton, degrees are taught over 2 teaching periods or semesters. Students study 8 modules per year, about 4 per semester. Each module has 2 one-hour lectures and between 3 and 6 hours laboratory practical work per week. That's an average of 25 contact hours per week, and of course does not include the 180 hours of fieldwork contact per year. We strive to make our geoscience degrees student-centred and place a strong emphasis on the skill set demanded by employers. We're proud of our fieldwork programme, and to tell you more about this, we'll pass you over to one of our current students, Katie.
Hi, my name is Katie and I'm a 3rd year geology student here at the University of Southampton, and I'm here to talk to you a little bit more about the fieldwork you'll do if you're thinking of taking geology or environmental geoscience here. Fieldwork has been a big part of my degree, providing me with great training in all aspects of geology and giving me a head start in digital mapping techniques. Most of all, the residential field trips allow you to bond and make memories with your course mates. On first year trips, you learn all the basics you need to know, and you don't need to have studied geology before. We learn how to observe and record data in the field and start to think about the processes that have shaped the world around us. In the Easter of second year, we visit southeast Spain and explore the sediments, volcanics and mineralisation there. This was great preparation for our summer mapping project at the end of year 2. I carried out my mapping project in Scotland, whereas others went to Spain and Cyprus. The cost of travel and accommodation for compulsory field courses is covered by the university, so you just need to buy your food and drink. I aspire to be a volcanologist, and my favourite field course was the third year volcanology trip to Tenerife, where we got to study the spectacular pyroclastic flows and lava flows on the flanks of Mount Teide. If you choose the 4-year integrated master's course, there is more fieldwork, this time with a focus on data collection and teamwork. This helps you to develop skills required in the environmental, engineering and resources sectors by employers.
Thanks, Katie. At Southampton, we try to get our students involved in our research wherever possible and provide opportunities to work in the diverse range of geoscience laboratories at the Whattoff campus. This experience is a great asset to have on any CV, giving you a head start in the job market. We encourage our students to apply for research placements. Josh here spent 2 months in Japan at a volcano observatory, and his results are now published as a paper in a major international volcanology journal. These guys got a funded placement in Namibia, working for a rare earth element exploration company, and they based their research projects on the samples they collected when they got back to Southampton. George is now working for Impact Minerals in Australia, and Matt is working as a mine geologist in Cornwall. To tell you a bit more about the MSci, the 4th year and her research project, over to one of our current students, Phoebe.
My name is Phoebe and I'm a 4th year MSci Geology student at the University of Southampton, and I'm here to talk to you today to give you a little bit of an insight about 4th year, and I'll be mainly focusing on the independent research project. So 4th year itself is quite a step up from the previous years in the terms of the quality and the quantity of your work you'll be submitting is at a lot higher standard. This does sound quite intimidating, it's nothing to worry about. The year is completely manageable and I fully recommend doing it. So choosing your independent research project will happen at the end of your 3rd year between May/June, where you'll be in contact with the relevant lecturers who are offering the projects for you to choose. So for me, I worked with Dr. Geological Mapping on a project involving carbon dioxide capture and storage, where between September and December of my 4th year, I designed and I performed experiments, and then from January all the way through till May, I collected data in various ways, I analysed it, and I produced a 10,000 word written report, and I did a presentation. So from my commitment to my 4th year, I gained an invaluable skill set from being able to communicate effectively with others, from being able to computer program, from being able to analyse data, and from being able to public speak, as well as various other skills. And as well as I also gained some amazing contacts, that's always a bonus. So overall, I fully recommend coming to the University of Southampton for a well-rounded university lifestyle, as well as being properly set up for the real world as a geoscientist.
Thanks, Phoebe. To help our students get the career they want, we invite our successful graduates back each year to an event to tell our current students how did they get their job, what did they put on their CV, what were they asked to interview, what skills are the companies after, what pathway gives you the right experience. It's worth mentioning that geologists are in demand, and this is demonstrated by the UK government shortage occupation list, as shown here. Engineering geologist, hydrogeologist, geophysicist, geoscientist, geologist, geochemist, senior resource geologist, staff mining geologist. There's clearly a common thread running through this list. Our graduates get jobs. 98% are in employment within 6 months of graduation. So it's worth remembering geology and geoscience are vocational subjects, and this is borne out by the fact that 3/4 of our graduates become professional geologists. Well, thank you very much for listening, and I hope you found it informative, and we will be available online to answer any questions you may have. But if you are thinking about geophysics, then please click the link to follow the geophysics subject talk below.